First of all, I can only congratulate you to your choice of R. It's a great choice and generally compares well to its peers like SPSS, Stata, MATLAB, SAS, and so on. In this video, we will take a look at the key traits of R. I will also show you how to work with those add-on libraries or packages which you hear so often about and which are so important in R. Basically, what I will do in this video, I will explain the following sentence in detail. R is an open source, high-level programming language used for data analytics purposes. Each of those nerdy sounding terms has specific implications which we need to discuss in the next minutes. Open source does not only tell you that it is free, it also means that everybody can provide extra functions in the form of libraries. This inevitably leads to a modular package structure of the whole R system. High-level programming language means that R has functions and object classes already defined. And data analytics is quite clear from the get-go. If you are searching for pure web development tools, you probably can save your time and look into Python or Java-based web frameworks. So let's start with the easiest part of our sentence, data analytics. The underlying question here would be, what can R do for you and what are the alternatives? As an advanced analytics tool, R is able to perform data entry, although the features for direct data entry are sometimes limited in R. Data pre-processing tasks like cleaning, changing, deleting or filtering data, statistical analysis including modeling, machine learning and prediction, data simulations to varying degrees, data visualization up to complex graphs. Nowadays R has web scraping functionalities, especially for Twitter analytics. R even has a data visualization framework for website integration, and this is called R-Shiny. If you perform data analytics tasks, R has you covered in 95% of the cases. In general, there are no disadvantages with R compared to the other costly players. However, depending on the field you are in, there might be preferences towards a given software. MATLAB, for example, is preferred by engineers. Minitab is widely used in quality control and Six Sigma applications. SAS is still the go-to product in clinical research and drug development. If you're planning on working for a pharma company, you want to submit clinical trials data to the FDA or the EMA, there is simply no way around SAS. SPSS is widely used in academia, especially in the social sciences, but R is gaining terrain quickly here. Basically, if you are looking for a career in academia, chances are you will have to transfer from SPSS to R at some point. Of course, Excel has some overlap with R. Data entry is much easier in Excel and quick visualizations might be easier in Excel as well. In general, when you are working in data analytics, there is no way around Excel. It is still the best way to communicate data to colleagues who lack deep analytics training. Overall, I can confirm that R is getting more popular by the day. The community is growing, which helps R to adapt to new developments very fast and in high quality. So now we will tackle the term high-level programming language of our sentence. So what is a high-level programming language? Generally, R is considered such a high-level programming language. This means that R gives you tons of predefined functions and object classes. Your task is only to find a proper function and supply the correct specifications to the function in form of arguments. That makes it much easier compared to low-level languages like C, where you have to tell the computer bit by bit what it should do. Plotting a histogram is as simple as typing histx in R. That would be impossible in C. Your responsibility as a programmer has now shifted from building a function totally from scratch to programming a pre-packaged function in accordance with your needs. You do this by feeding information into the function. This is done via the function arguments. And each function has a set of arguments which you can use to tailor this function. Next, we will discuss the term open source and its not so obvious implications to R. This also leads to the question of the R structure. So what does open source mean in this context? What is the structure of R? R is actually quite old. There are different interpretations of the birth date of R. Some might argue that the first stable version came out in 2000, which is of course correct. Others, including me, think that the year 1988 was the true birth year. This was the year when the new S language was published, and this language S is the basis of R. The documentation of many R-based functions still reference to this publication. When it comes to the structure of R, it is clearly visible that this is a community-based project. You can see the organic growth over decades. You have RBase, which is the very core of R. This is more or less the material you get when you download R. And there are the many add-on packages contributed by the ever-growing user community. RBase reflects the original intention of R, which was a statistics language. Therefore, RBase has a strong focus on statistics, data visualization, and general data handling. There are even exercise datasets implemented in RBase. The very famous Iris and MTCars come to mind. R is open source, which means it is free to use, and this also means the user community is required to keep the program up to date. In fact, the community is growing each day. The number of add-on packages is nearing 8,000. It is general consent that R is comparable, and in some cases even superior, to all those proprietary statistics packages out there. That means R is playing in the same league as expensive Stata, SAS or SPSS and so on. Clearly, much of the power of R lies in the add-on packages or libraries. They are basically collections of functions for a given topic. For example, Hadley Wickham, a member of the RStudio team and creator of many quality packages, wrote ggplot2. This package provides a whole new method of data visualization in R. It is a standalone alternative to RBase graphics tools. Now, it can happen that over the years 5 or even 10 different ways have evolved to do the exact same thing. That means some functions in the packages are providing solutions for problems that have already been solved several times. The author may have found that the tools available are insufficient, or he or she just wanted to make a name for himself by submitting another package. At the moment, I know of at least 5 different functions for histograms, so there is certainly some redundancy in R. But overall, a community-based add-on package system worked very well for R so far. Alright, so finally, let's take a look at those community-based add-on packages. I will show you how to install and activate a package. This is extremely important. You will have to install or at least activate packages quite often when working with R. In RStudio, it is really easy to manage your packages. At the bottom right corner, you simply go to the Packages tab. Here you can see the packages that you already have on your machine. The system libraries came with the installation. This is RBase, the core of R. And you also have the user libraries. Those are the ones that you downloaded from the web in the past. Getting an add-on package ready to work is a two-step process. You need to download it once from a repository, and after that, in step 2, you need to activate it. But this you must do in each R session you want to use this specific package. So let's say in this case I want to use the library Plotrix. It is a data visualization library that has nice extra features to R-Base. For example, the gap plot is really recommendable from this library. By the way, in this tutorial I will be using library and package synonymously. Both are, at the core of the meaning, a collection of functions. To download Plotrix, we simply go to Install Packages, and in the window we select Plotrix and press Install. Now the computer would get the required files from the online repository. Note that most packages have dependable packages which will be downloaded automatically. That means installing a package does almost never mean that you are going to download only one package. There will be dependables downloaded as well. We could also use the old R way and code it by install.packages, which would do the exact same thing. So now that we have downloaded the package Plotrix, it should be available here in the user libraries list. Note that we cannot use it right away. It needs to be activated first. So let's say that we want to activate this package Plotrix. It is already in this library list because we just downloaded it, but the box here is not ticked. That indicates that it is not activated. Just tick it and you're ready to go. Alternatively, you could also code library and in brackets the name of the package. It is very important for you to keep this command in mind. Whenever you want to use code that has the library or the require command in it, your alarm bells should go off. Add-on packages need to be installed and activated to run this code. With this X button over here at the very right corner, you can remove a package again. You might find that a given package eats away on your disk space or it contains functions that block another one. This number over here is the indicator of the version number. In general, I am updating R every 9 months. Whenever I do this, I am also installing RStudio anew. Especially RStudio has been busy implementing new tools, so you might not forget to also get a new RStudio from time to time. When I update R, I also update all packages or download them anew. Again, 9 months worked for me so far. Others suggest 6 months or even 1 year. At the end, the time span is up to you. If you click at the library, you are redirected to the package's documentation. This is the place where all functions that are housed in this package are listed and explained. The function documentation has a strict convention which is followed throughout all R packages. For the more popular packages, you might even find a vignette, which is a brief tutorial that guides you through the most important features of the package. Alright guys, let's recap what we learned in this video. We were discussing the general traits of R, which I put in one sentence. R is an open source, high-level programming language used for data analytics related purposes. Basically, that means that the R user community contributes to keep R free of bugs and up to date. R is used whenever you want to extract information out of data. And R has functions already available, you only need to set the right parameters. R is a programming language, that means there is code to be written. RStudio, with its click interface, makes it easier, but at the end of the day, you will have to code your way to the results. And at last I showed you the 2 steps of working with those add-on packages. Don't forget, download a package once, but activate it in each session you want to use it.